Hi everyone. In this video, we are going to learn the basics of Docker with hands-on demos. We will cover what Docker is, why we need it, and how it's different from virtual machines. We will also look at some basic commands and finally build a Docker image. So by the end of this video, you will have a solid foundation to explore Docker further. So what exactly is Docker? It is a platform that allows us to build and run applications inside containers. So you may ask, what is a container? So containers are lightweight environments which have everything included within them to run the application standalone. So for example, we have this Redis GitHub repository, and these are the instructions to build Redis from source. So you have to install the required dependencies, use the GCC compiler, use CMake, then a bunch of changing directories and downloading some other dependencies and all. Then finally using the make command, etc. And there are other um, for like Ubuntu 20.04. These are the command. These are the methods for the other versions. These are the methods. So it is a very hectic uh, process to start with. But we can do the same thing with Docker and it won't really take much time as well. Instead of doing all this setup, we can just run this command and we will have a instance of Docker running with us on our local system immediately. That's why we use Docker, and it also helps in making sure that the app that we created, even on our laptop, it will work in the same way on any other's laptop or desktop or any server on the cloud as well. Then you might also have this query that these kind of environments are also provided by the virtual machines. So why not use virtual machines and why use Docker containers instead? So to answer that, we can look at the differences between virtual machines and containers and why containers are more advantageous. So a virtual machine is a software-based uh, mimicking of a real physical computer. So there is a guest operating system running on top of your main operating system and is like a separate machine on its own. It has isolated RAM, CPU, and process allocations. All of these are virtualized. So you have the base infrastructure. This you can assume as the hardware. And then you have a hypervisor installed. So a hypervisor is a software that sits between your hardware and your virtual machines, and it has the ability to allocate resources to each virtual machine. And there are two types of hypervisors which are available. One is a type 1 hypervisor, which is like VMware ESXi and Microsoft Hyper-V. And there are some which are on the software level, which run on top of a host operating system. For example, Oracle VirtualBox and VMware Workstation. So you must have heard about VirtualBox and Workstation, VMware Workstation, if you have worked with virtual machines. That's how VMs work. How is Docker different? So Docker uses the host operating system itself. The kernel from the host operating system is shared between all the containers running on top of the Docker engine. So basically, they are much lighter than virtual machines as they share the host's operating system kernel, and has they have their own isolated processes, file system, networks, and all. But basically, because um, the main component, which is the kernel, is shared with the host, they are very fast to start up and stop. I hope these diagrams make it a bit clearer on how Docker and virtual machine are different from each other and what are the advantages of Docker when compared to um, virtual machines. There is also one thing that you may guess ki when should we use virtual machines instead of containers? So we should use virtual machines when we need complete isolation. So as you know, for containers, the kernel is shared. Let's say app A is able to exploit some kernel level vulnerability, then it can affect app B and app C as well. But that is not possible in virtual machines because app A has its own kernel running on top of the hypervisor. So they are much more isolated and much more secure in these cases. Let's go to some practical examples. So the next step would be to install Docker. If you're on Mac or Windows, the setup is quite straightforward. You can just download Docker Desktop and install it. It will be a one-click installation. You may have to enable some settings in Windows for enabling WSL2, but I'm not covering the installation part here because that can be done separately by following these docs. So let's say you have Docker installed. I'll just show you that I have Docker installed. We can run this command docker hyphen hyphen version, which will show the installed version of Docker if you have it working correctly. Otherwise, it won't show up here. And I also have Docker Desktop installed. So this is Docker Desktop, and I have some containers also here created. So a simple overview of the Docker Desktop I'll give. Uh, you are mostly going to be concerned with these three tabs: containers, images, and volumes. Other tabs are also important, but to start with, you don't really need to understand about those. Here you will be able to see the containers which you have created. Here will be some of the images which you have downloaded from the, let's say, Docker Hub, or created your own images. And volumes are actually storages which help in containers to have some persistent storage, because containers can be exited and destroyed or stopped at any point of time. So if you have done some changes and you want the changes to persist, you can create a volume and store that data there. So let's now go ahead and create our first Docker container with the most common Docker image which is used. So you can type docker run hello world. So hello world is a base image which is available in Docker Hub, and it is the image which Docker recommends you to test your Docker setup with. So I'll explain what happened here. So Docker wasn't able to find the image hello world on my local system. So it went ahead and pulled the Docker world image from the Docker Hub. And as you can see, this is the message getting generated from our container key. The Docker client contacted the Docker daemon. The Docker daemon pulled hello world image from Docker Hub, and basically it means कि your Docker installation appears to be working correctly. So after this, let's say you want to know which other images are present. Now let's say you want to use a Docker image of Redis, or let's say MySQL as a dependency in your project. So how will you know that image exists in Docker Hub or not? So for that, we have the search command. So every Docker command is going to be prefixed with Docker only. So this part is going to stay common. Then your actual function will be entered, Docker search. Let's say I am searching for MySQL. So it will search uh, the Docker Hub for MySQL usages, and you will see the official image as well as various other images published by other people, like Alios MySQL, ddev MySQL, and this is the official one. You will have this official equal to OK flag in front of it. Let's say we want to use this itself. So to do that, what we can do is docker pull MySQL. Basically, it is going to pull MySQL image from the Docker Hub into our local system. So image is just a blueprint. a blueprint which is used to create actual containers. So image on its own doesn't really do anything. When you create a container from the image, that is what is the actual application. So now that we have pulled this MySQL image from the Docker Hub, I can also show you that we have this MySQL image now and in the Docker desktop, and also this hello world one which we just downloaded. And also in containers, you must be able to see that I already had these first, second, and third containers, and a new container with this random name has come up, which was which is using the hello world image. So now we will run this MySQL image. So to see what images are available, we can, sorry, not Docker image, Docker images. Yes, this is the command line view of the same. So let's say we want to run this image now. So docker run -i t mysql bash. So it has started as fast as that. So you can see another container called recursing point care has spawned up and it is in the running state. As you can see, I can click on the stop button to stop it, and the image of MySQL is being used for the same. So now let me show you how to run an Ubuntu container using the Ubuntu image. I already have the Ubuntu image on my local, but if you don't have it, it's all good because Docker is going to download it from Docker Hub anyways, and it is going to work as as it is going to work on my computer. So docker run -it Ubuntu and bash. So what does this command mean? So docker run is the command, -i is a flag, which means I want to open this container in the interactive mode, and -t shows that I want it to be attached to a terminal session. And I want to access the bash shell of this Ubuntu image. So when I hit it, you can see the starting of the prompt changes. So it means we are now inside the container. And this 8F8A4B4, this is the uh, container ID, which you can see is matching here. So we are currently inside this. So you can run Ubuntu commands here. And this is not the same directory which my computer has. We are inside the Docker container at the moment. Yep. So to exit out of the container, you can type this command exit, then it exits, and I'll just show you ls here. As you can see, this ls now lists the file which is on my own computer. Let me show you Docker Hub as well. Let's go to Docker Hub. Yep. Let's say I am interested in downloading, let's say, Alpine. Alpine is a lightweight Linux image, and I want to show you the usages of tags. So when you mention this command, let me clear the terminal. When you mention the command docker pull Ubuntu, Ubuntu, you can see it is saying using the default tag latest. So what does that mean? It is downloading the latest version of Ubuntu image available on Docker Hub. But let's say I want a specific version. So I can come to this hub.docker.com and search for the image I want, let's say Alpine, and then let's say I want a specific version, 3.20.7. So you can see whenever you click on any version, this command is getting updated. So this part after the colon is called the tag. You can copy this, come to your terminal, paste it, docker pull Alpine 3.19.8. So it is pulling Docker, downloaded the image. Now let's say I want this version as well. So we can do that. And we can have multiple versions of Alpine running at the same time. So coming on Docker desktop, you can see Alpine with this tag and Alpine with the other tag. Both are available now for us to use. Run -d new container Alpine 3.19.8. Sorry, my bad. Name. Now if you want to see what are the currently running containers, you can come open your terminal and you can write docker ps, right? There is one container running, which is the Alpine one, and the same can be seen from this Docker desktop view as well. And if you want some more details, then you can do that with docker ps and -a flag. It gives a bit more detail about the same thing instead of docker ps. So container id, image, command, created status, ports, and names. What is different between this docker ps and docker ps -a is, even if any container is not running, it will show up in the docker ps -a. Docker ps shows only the currently running containers, which is the Alpine one at the moment, and docker container ps -a shows all the containers which are available. And here the status is visible, key up about a minute, and others are exited some time ago. Right. So we can also remove some containers. Let's say Docker, let's say I want to remove this Ubuntu container. So I can copy this container ID, Docker rm, and container ID. That's it. This container is gone. So now if I do docker ps -a again, you can see this 8fa4, that container is no longer listed here. Similarly, we can also remove images. So let's view all the images that we have, Docker images. Let's say I want to get rid of this Alpine version 3.19. So we can copy the image ID and docker rmi remove image and paste the image ID. Okay, sorry. So there is one thing which we need to take care of. You cannot remove any Docker container or Docker image if it is in running state. So you cannot delete a container which is in running state. You need to first stop it and then run it, then delete it. And similar thing goes with the image as well. So if a Docker container is running with a particular image, that image cannot be deleted. So we will first stop the container. So how to stop the container? It's pretty easy. Docker stop and container ID. So in this error response is so clear that what is the issue. Error response from daemon, conflict, unable to delete this image. Image is being used by running container, this one, 4497, and we can see when we did the docker ps -a, 4497 was the one which was in running state. So we can pick this container ID, we can copy this container ID and run docker stop, paste it. It's taking some time and it has been stopped. When it stops, you get the container ID as the output of the of the command. Now we had tried removing this image. We can again try to remove this image. Yeah, so I tried to remove the image again, but I got another error that the image is being used by a stopped container. So even if your container is stopped, you cannot delete the image. You will have to remove the container first and then delete the image. So docker rm container id, we'll have to copy again. We've removed the container. Now we can remove this image. Yes, Alpine 3.19.8 has been deleted now. Same things you will be able to see in the Docker desktop also. It is just the GUI of the same. So let's say now we have some basic hands-on experience with the Docker containers and image commands. Let us build a Docker image of our own. So for that, let's go back to the terminal, clear. Let me see my current directory. Okay. I'll make a new directory here, mkdir. So the command for that is mkdir make directory, my app, and let's say I'll feed into my app as well, change directory into my app, and I'll create a, let's say, Python file called app.py, and I'm going to just simply say print hello from the Docker container and close the bracket, right quit. I'll cat app.py to see the contents. Yeah, the contents are correct. Now, what I did with vi, you can do it with any graphical text editor also. You don't need to specifically use vi. You can use nano as well. So now let's create the Docker file. So for creating the Docker file, we need to create another file, and the name of the file will be Dockerfile. Here we need to input some commands. We first need to say what will be the base image of this application, of this Docker image. So let's say we choose Python 3.9 Slim as our base image. So how did I find it? You can go to Docker Hub, search for Python, official Python, and there are multiple versions of it. So some simple tags are present here. So I had chosen one of the slim versions from here. So if I do Control F, 3.9, 3.9 slim. This is the one which I'm using. Yeah, this is the Docker file of that base image. So images themselves are made up of Docker files, and we can use our the existing images to create our own Docker files. So let's come back to our Docker file from Python 3.9 Slim. Copy app.py, which is our file, to app.py. What does this mean? It means copy this file called app.py from my computer to the current directory app.py inside the container. So these commands are also executed while the container is being started up. So after that, we can go ahead and add the final command for this simple app, cmd python comma app.py. cmd means the command which needs to be executed inside the container. So we are going to run python app.py inside the container. So this container is going to output the print statement which we earlier wrote in app.py. So I'm going to right quit this file. So hello from the Docker container was the string which we wrote inside app.py. This Docker container which we will create from our new image is going to output this thing. So now we have just created the Docker file. A Docker file will be used to create the image, the Docker image, and then that Docker image will be used to create our container. So now we have the Docker file. We will now create the Docker container, Docker image. So how to build the image? Docker build. Docker build is the command. -t, let's say my Python app, and I'm going to give it a random version, 1.0, and we have to specify the current directory. So I'm going to give dot. Dot specifies the current directory, and enter. It will start the building process. The build has started. It will pull any dependencies which are required, and it has created it from the Docker file. So to see if the image is created or not, we can go to Docker desktop as well. My Python app image has been created under the images section. Now, just like we were running the containers of Ubuntu, MySQL, Alpine, Redis, whatever, we can run our app's container as well. So for that, we can do Docker run my Python app 1.0. That's the name, right? Yeah, I guess my Python app should be sufficient. Okay, wait, I'll have to put the tag as well. Yep. So when I just mentioned Docker run my Python app, it assumed colon latest is present in front of it and it tried to fetch the image from Docker Hub. But I wanted to use the one which I have locally, so I had to give the tag as well. So as you can see, Docker run my Python app with our tag is giving us the uh, response from our container, hello from the Docker container. And if you go to containers, you can see another container called Zealous Einstein was spawned up. It printed our command and then printed our output, and then it exited 37 seconds ago. So that's how you can run your own. You can write your own Docker file, create a Docker image out of it, build a Docker image out of it, and then you can run it as a Docker container. So we have covered what Docker is, why it's used, how it compares with virtual machines, learned some basic Docker commands, and created our first Docker image. So yeah, thank you so much for watching.